All right, the notes explaining that because I changed the review and updated it, but I had made this video in the past, I am just trying to actually add the segments that I changed and just insert them with a video editor. But all the problems should be the same. I just wanted to let you know it may not be the same number as your problem, but the problems are exactly the same. All right, let's keep going. I need to go to 10. All right, solving by any method. I happen to notice that these both are squares, and since they're both squares in the front and the second term, this is a difference of squares. I'm actually going to factor into two sets of parentheses, and I want to do 5x and 5x because that's how I'd break down 25x squared, and then 1 and 1. Because it's a difference, I need 1 plus parenthesis and 1 minus parenthesis. Now, we always talked about how we split and then set each equal to 0 and solve. All right. Split right down between the parentheses, set each one equal to 0, so 5x plus 1, set that equal to 0. Set 5x minus 1, set that one equal to 0. So my answers are going to be similar, but not exactly the same. Now, if I move my 1 over here, it's going to end up equaling negative 1. Then I'm going to divide by my number in front of x. So I'm going to get x is equal to negative 1/5. The second answer, if I move negative 1 over there, it's going to change to positive 1. Then when I divide by the number in front of x and divide by 5, I get x is equal to positive 1/5. So my answer is the solution set of negative 1/5 and positive 1/5. That would be the two numbers that I'm looking for. Solve by any method. Number 11. It's already set equal to 0, so I'm probably going to try to factor the trinomial. And when I do, I get x and x. I'm trying to think of two numbers that multiply to give 16 that add to be 10. I think 2 and 8 fit the bill. Now they have to add to be negative 10. So that tells me I need a negative 2 and a negative 8. Just like the last problem, we're going to split, set each equation equal to 0, and solve. Set each equation equal to 0 and solve. When you move 2 over, you get positive 2. When you move 8 over, you get positive 8. The answer is the solution of 2 and 8. Number 12. Solve any method. Now, I'm actually going to use the square root method on this because I noticed that I have parentheses with a square over it. How do you undo a square? Well, you take the square root. So that's what I'm going to do. I'm going to take the square root of the left, and if you do that to the left, you have to take the square root of the right. Now, my square root and my square cancel each other. So what used to be under the square root comes out exactly the same, 2x plus 3. But the square root of 36 is 6. But you're not supposed to forget what? Don't forget plus or minus. So that's actually positive 6 and negative 6. Now to solve for x, I'm going to subtract 3 from both sides. When I do, I still have 2x on this side, but I'm going to use both numbers, okay? I'm going to, for a second, I'm going to ignore the negative, and I'm going to use the positive 6. Positive 6 subtract 3. That would give me positive 3. Then I'm going to hide the plus sign, and I'm going to use the negative. That's negative 6 minus 3, which is negative 9. So I'm going to get two answers. I'm going to get 3 comma negative 9. Now, I actually am not finished. I need to divide by whatever number's in front of x. That actually means both solution of numbers gets divided by 2. So I actually get 3 halves and negative 9 halves. If you change those to decimals, you would get 1.5 and you would get negative 4.5 if you had to change those to decimals. I'm fine with the fractions. All right, next problem we're going to move to is one that's labeled 13. We're going to use the quadratic formula. So when I use my quadratic formula, a turns out to be the number in front of x squared, so a is a 7. B is the number in the middle, so B happens to be 10, and C is the number with no x, and it happens to be 2. Now I'm going to substitute into the quadratic formula. We learned it with a song. Opposite of B, plus or minus square root, plus or minus square root, B squared minus 4AC, B squared minus 4AC, all over 2A, all over 2A. All right, So the quadratic formula is something you will have to remember. It's probably not going to be provided to you on the exam because I do not have an information sheet that you will be given. So hopefully this song is helpful if you need it. All right, so opposite of B. I always like to do opposite of B because that's telling me I'm going to have negative 10. 10 is already positive, so that's going to make it negative 10. Plus and minus the square root of B squared. And I like to square that number ahead of time, so 10 times 10 is 100 minus the 4 that's built into the equation times an A number of 7 times a C number of 2, and then all of it over 2 times A, which is 2 times 7. All right, the first thing that I want you to do is I want you to get your calculator, turn it on. I have mine out and we're turning it on. The first thing that we're going to do is we're actually going to take and we're going to actually pull the numbers that are underneath the square root, but not the square root. Pull those out, type them in our calculator. So we have 100 subtract 4 times 7 times 2. So, whoops, looks like I didn't get the 1. Let me make sure I do that. And 100, there we go. Press enter, and 44. All right, so that tells me that this is going to simplify into 44. Negative 10 plus or minus the square root of 44 divided by 14. That really doesn't match any of the answers. I've got 14 here, but it's negative 5 plus. So I'm going to say A is already out as a choice. I know that we should be able to simplify the square root. That should be 4 times 11, so what comes out should be a what? 2. So now I have negative 10 plus minus 2 radical 11. There's something else that you need to remember. 14 is a common denominator. That means it goes under the 10 and it goes over the second under the second term as well. So I'm actually going to have over 14 over 14. If possible, I will simplify the fraction. 10 fourteenths, 2 goes into both numbers, and I should get negative 5 over 7. All right, 2 fourteenths, 2 is on the outside, 14 is on the outside. I should get plus minus 1 over 7. And then, of course, I didn't do anything. The square root of 11 is still there. Now, if we bring this back together, does it match any of our choices? Well, once I factored it down to 7, I no longer have negative 10, and I don't have 39 under the square root. It actually matches when we check it. We're going to do negative 5 minus and negative 5 plus square root of 11 divided by 7. So C is the correct answer, and I had to simplify and work within my quadratic formula. I just gave you an example to make sure that you had to go back and had to use the quadratic formula. 14. You're going to solve by completing the square. This is something that we did this year, something I've added to the review. When you do completing the square, you remember one day we talked about completing the square, and we would talk about having maybe big sections, and then we would have some small boxes here, and maybe we'd have a long box there, and we would say, how many do we need to add to complete the square? Okay, so we may have to add some pieces. Well, that's what we're talking about. To complete the square, I'm going to half the middle number and square it. So half of 8 is 4. 4 squared is 16. I need 16 and I have 7. So the first thing I'm going to do is I'm going to actually move 7 out of my way to the other side of the equation. So I'm going to have x squared plus 8x, and I'm going to leave some space, and on the other side, when I move 7 over, it became negative. Now, we just said that if you half 8 and square it, you're going to need 16. So I'm going to come in here, I'm going to add the number I need to complete the square. Well, if you add it to one side of an equation, you're going to have to add it to the other side of the equation. So this is going to factor now, and hopefully it's a perfect square. X and x, 4 and 4, plus plus. Since the two parentheses are the same, it's x plus 4 squared equal to, now we have to deal with the other side. Negative 7 plus 16 is 9, so now we're equal to 9. Now I'm ready to complete the square. I did that, and I'm going to solve it by getting rid of the square. So the square root and the square cancel. You get x plus 4 out, but x plus 4 is equal to square root of 9. Square root of 9 is 3, but we can't forget what? When you take square root on the very next step, plus or minus. Now, to finish this, to get two answers, I'm going to bring this over. When I do, then positive 4 is going to become negative 4. I have to do both of these numbers to get two answers. First, I'm going to use the positive 3. Positive 3 minus 4 is negative 1. Then I'm going to take the negative 3. Use negative 3. Negative 3 minus 4 is negative 7. So I have two possible answers, negative 1 and negative 7. All right, number 15, solve by completing the square. So another one, same thing. Let's see if you can remember. If you want to challenge yourself, pause the video. All right, we're going to work together. I'm going to move 100 over there. X squared plus 16x. When I move 100 over there, it turns out to be negative 100. Now, I'm going to look at the middle number. We're going to half it, then square it. Half of 16 is 8. 8 squared is 64, so I'm going to add 64. You add 64 to one side of an equation, you're going to have to add 64 to the other side of the equation. This should factor into two parentheses just alike, x plus 8 and x plus 8. Negative 100 minus 64 is negative 36. I can rewrite x plus 8 as 1 parenthesis squared is equal to negative 36 because I was trying to make it become a perfect square. Now, to undo the square root, we're going to take the square root of one side and the square root of the other side. This side I know I get x plus 8. Something interesting happens on this side. For the first time in my review, I have run across a negative underneath the square root. Do you remember what the square root of negative 1 was? This is the first year that we've had to talk about imaginary numbers in Math 2. Square root of negative 1 comes out as imaginary letter I. It's the only imaginary letter we have. So the negative comes out as an I. So I know I'm going to have an I here. It turns out the number part, the 36 part, that's 6 times 6 or 6 squared. That's going to come out as a 6. So not only does an I come out, but the 6 comes out. And remember, don't forget what? Plus or minus. So one step to go. The only thing I need to do now is I need to move 8 to the other side to get x by itself. It's going to become a negative 8. So x is equal to negative 8. And then I'm going to keep the plus minus that was in front of 6i. Because that has an I, it cannot be added. You cannot add that to get 14, or you can't do it like negative 8 minus 6 is negative 14 or negative 2. You cannot add it. You have to leave it just like that. All right. When we start the next section, this is Unit 5. This is the new small unit I added that was application questions. And so a lot of these, you can use your calculator. So make sure you get your calculator out. Make sure that you open it up. Make sure y equals, clear anything out. Make sure that plot 1, if it is black, make sure that you turn those off. So like I'll press enter, and when I go back down, nothing up the top is highlighted and y1 is clear. All right, first thing we're going to do is we're going to type this equation in our calculator. Negative 20.8 x squared, here's the shortcut key for x, it's up here next to the alpha, square, plus 458.3x plus 3,500. All right, make sure you double check that you have it typed in correctly. Now, my question says, suppose that equation represents the cost of a car between 1964 and 2000. X represents the years since 1964, so I'm going to keep that in mind. Which year has it had the greatest value? So I'm focused on the greatest value. So I'm going to go to my table. So if you want to jot some stuff down, we're going to use the table. So put the equation in y1 equals, then we're going to use the table. So that just kind of lets you know where we're going. So now I'm going to go to the table, and I'm going to go back and make sure mine starts at 0. So at 0, looks like my value, my cost was 3,500. Then it went to 39, 43, 46, 5,000, 52, 55, so it's increasing, 5,600, 5,800, 5,900, 6,000, more than 6,000, came back down to 6,004. So it looks like it happened at year 11. Do y'all see that it happened at year 11 when it had the maximum? And now if I keep going, my value of the car is coming back down, so it's getting older and older. So at the table, it was at X11 where it was the greatest value. So my answer would be 1964, and it would be 11 years since 1964. So if you add those 11 years, you get 1975. It was A. My chance at choice is at A. All right. Number 17, the ball is kicked off the ground after 5 seconds. Its height is given in an equation, negative 16t squared plus 64t. At what time does the ball reach its maximum height? We can do this with our calculator. Go to Y1, clear out the old equation. So here's what I'm going to do. It says, after 5 seconds, its height in feet is given by the equation. At what time does the ball reach its maximum height? So we're going to go and we're going to type in the equation, and my equation's negative 16t squared. I don't have a t, I'm going to use x square, use a shortcut key for square, plus 64t, which I'm using an x. So x represents time, h is represented by y. Okay, so I don't have h's and t's, I have y's and x's. So that's time and height. Now, I'm going to look at my table. If I look at my table, I'm going to have to go all the way back up to the top. It looks like at 0 seconds, I'm at 0 height. At 1 second, I'm up to 48. At 2 seconds, I'm up to 64. At 3 seconds, it looks like I'm back to 48. At 4 seconds, I'm back to 0. So this looks like a perfect up and down motion from 0 seconds to 4 seconds. Now, looking at your data table, what time does the ball reach its maximum height? So this is pretty symmetric. So it looks like it reaches its maximum height at what? 2 seconds. And at 2 seconds, we're at 64, and that's the highest that you'll ever get. You can change your window. We will not look at negative time. We're only going to go for up to about 5 seconds, give ourselves a little baseline. This thing, I'm just going to put 50. And let's just take a look at our graph. Looks like it goes higher than 50. But looking at it, if I change my y height, y max would represent the maximum height. So let's just change it to 100. It's just review. So I can see that it comes up as high as it can go. So by the time it leaves the ground, goes up to its height, it's at 2 seconds, and then it's back down. It didn't ask me what the height was. It just said, what time does it reach that height? It reaches it in 2 seconds. All right, 18 and 19 are kind of real short, quick answers. Nothing that you actually have to calculate. You just got to realize what you have. If you will remember, there is a basic formula for the height, and it's usually got negative 16t squared. Then it will sometimes say v sub 0t plus h sub 0. Those numbers that you see actually represent your initial velocity, or how fast it was going to start with, and the number at the end tells you its initial or its starting height. Okay, so all I'm asking you for in 18 as 19 is, do you recognize the information that's given to you already in an equation? So here's our function, negative 16t squared, 32x, 240. Depicts the flight of a cannonball shot from a cliff overlooking the ocean. How high is the top of the cliff? In other words, how high is this cannonball when it's at the top of the cliff when they're shooting it off to begin with? I'm really asking you for the initial height, okay? And actually, there's nothing that you should calculate. It's a recognition of what information you have. 240 tells me the initial height because it's the number at the end that's already there when I begin. So number 18 is simply C. Number 19, same function, same height, cannonball from the cliff. At what velocity? Again, the number that's actually built into the equation, the velocity is always the number in the middle with the letter T. Do you know what it is? It's not 16. It's not 240. I'm not calculating 256. It's there for me to pull out of the equation and recognize what information they're giving me. So that's a review of how we actually make our equation. Number 20, a ball is dropped from a building. How long will it take for it to hit the ground if the situation is modeled by this equation? Now, if we look at this equation, I know that 16 is a reference. It's actually a nod at gravity. That's where negative 16 comes from. It's actually half of gravity's value. I do not have a t term, but I do have a number with no t. So that tells me that this is at a height that I'm starting out at 200. So this building must be 200 feet high. Okay? And if I hold it out there and I just drop it, so it's 200 feet high, But when I drop it, its velocity to start with must be 0. So it's almost like you're just holding a penny out. You don't throw it up. You don't push it down. You just hold it out there and it's at 0 and you just drop it. So that's what we're talking about. That's the situation. And that's why we don't have a middle term, because you have 0 initial start speed. Okay, same thing with my calculator. Type it in our calculators. Go to y equals. We're going to change the equation to say plus 200, because that's the start height. That's my new equation. And my question says, how long will it take for it to hit the ground? All right, I'm always really fond of looking at the table. So it looks like at 0 seconds, I'm at 200, then I'm at 184, then I'm at 136, then 56, then negative. What happens, what does it mean when you're negative? It means that you've already hit the ground, and if you could actually plow into the ground, you'd be 56 feet underground. Obviously, that's just an interpretation. So it looks like somewhere between 3 seconds and 4 seconds, I've hit the ground. Now, I think you could probably figure that out between your choices. It's not 5.6. It's actually what? 3.5. Now, if you wanted to look at this on a graph, I like to make sure that you know how to change your window. So we're going to press window. X represents time, and we know that by the time this thing has gone 5-6 seconds, it's already back on the ground. So we'll just put 6 to give ourselves a little extra space. And we know that this thing starts at 200. Now I'm going to leave myself -10 just to see a little bit below, just to give myself a little space. This is a graph. Didn't work out that way. Oh, 2000. Didn't mean to do that. All right, here's the ball coming down. And if this is marked off 1 second, 2 seconds, 3 seconds, 4 seconds, when does the ball hit the ground or the object? Between 3 and 4 seconds or 3.5 seconds. All right, 21. The product of 2 consecutive even integers. These are the product problems that we've been working. So it's in our applications chapter. You saw them in Math 1. You're seeing them again in Math 2. We're going to go phrase by phrase, and we're going to write our equation. The product. Product means we're doing multiply problem. All right, we have talked about that the product means multiply. Then it says of 2 consecutive positive, well, I'll kind of keep that in my pocket for a minute, even integers. So I know if it says even, it's x and x plus 2. So I always like to write those on the left-hand side just to remember what they are. Now, I'm going to multiply these 2 positive consecutive even integers. So if I multiply these 2, I know this is going to be like the first one's x, and the second one is x plus 2. So I'm going to multiply these. Eventually, I'm going to have to do distributive property. The next thing I see is. So is interpreted as an equals. Then I see where it says 6 more than. So I'm going to add 6 to something, and it implies more than something. It implies there's something there first, and it's 6 more than that. 6 more than 3 times. So 3 times, okay, their sum. Sum means to do what? Add. And we're talking about their sum. So we're talking about summing things up, and I'm summing my 2 numbers. So I have to come back over here and add. So what is x plus 2? Well, when you add the numbers in front. So you're going to get 2x plus 2. That would be the sum of the 2 numbers. So that's what goes here, 2x plus 2. This part represents their sum. So it's all about interpreting one phrase at a time until you kind of get your equation. Now we're going to solve it. I'm going to x squared plus 2x equal to 6x plus 6 plus the other 6. And that's going to actually end up giving us 12. Now, our strategy whenever we have quadratics is to move everything to one side of the equals and set it equal to 0. So I'm going to bring 6x over here. That means it's going to change to -6. And I'm going to be 12 over there, which is going to change it to -12. So now I have equals 0. X squared plus 2 minus 6 is minus 4x minus 12 equals 0. Factor into 2 sets of parentheses. What 2 numbers multiply to give 12? That subtract to give 4. 6 and 2. Bigger number wins the sign, so -6 plus 2. Then we're going to do that strategy of split, set each one equal to 0. And I'm going to solve for 2 possible answers. The first one gives me x equals 6, and the second one gives me x equals -2. Now, because I need positive numbers, I have to discard the answer -2. So know that my 2 numbers are going to be 6 and 8. So 6 and 8 are the integers that I was solving for.